Welcome to The Explainer. Today, we're cutting straight through the hype to show you exactly how you can integrate generative AI into your enterprise Java applications. If you've been wanting to harness the absolute power of AI, but, without abandoning your favorite programming ecosystem to do it, well, you're in the right place. Let's get right into it. So let's just address the elephant in the room first, right? Have you found yourself in an interview recently, or maybe just sitting in a sprint planning meeting, and someone casually asks, "So, do you have any AI experience?" And you kind of just have to mumble, "Not really." Or maybe you've been watching all these other devs build autonomous agents and recommendation engines, and you're just sitting there wondering, where on earth does Java fit into the whole shebang? Look, trust me, you are definitely not alone in feeling a little left out of this AI boom. Because, let's be honest, for a long time now, the narrative's been completely one-sided. The whole AI ecosystem has been incredibly Python first. Like, if you wanted to play with large language models, you immediately looked to Python libraries like LangChain or Llama Index. But here is the massive disconnect. Think about the enterprise market. The vast majority of real, robust, scalable products out there, they run on Java. You really shouldn't be forced to build and maintain an entirely separate Python stack just to, say, add a smart chat feature to an existing Java app. It just doesn't make sense. Okay, let's dive into this. To really get a grip on things, let's build a mental model of what we're actually working with when we talk about AI models. I want you to imagine you have this neighbor, and this neighbor is a literal certified genius. I mean, they've read every single public book, every Wikipedia article, every open source GitHub repo, every blog post ever published. They are just unbelievably knowledgeable about the world. Now, because they've absorbed all this vast public training data, this neighbor is phenomenal at general tasks. If you go knock on their door and ask, "Hey, could you write me a quick poem about Java generics?" Or "Can you explain recursion like I'm 10?" They're going to fire back a flawless, perfect response in seconds. They've seen literally millions of examples of code and poetry, so synthesizing a brilliant answer is a total breeze for them. But, and this is a big but, here is the catch. What happens if you go over to that exact same brilliant neighbor and ask something like, "Hey, what did our biggest customers say in their support ticket this morning?" Or "What's the PTO policy in our internal company handbook?" You're just going to get a blank stare. Absolute zero knowledge. And why is that? Well, because while this genius neighbor has read every public book on the planet, they have never actually been inside your house. And that right there brings us to the absolute core problem with using off-the-shelf AI. These models suffer from two huge fundamental limitations. First up, knowledge cutoffs. The model was trained up to a very specific date, let's say April 2024, and it knows absolutely nothing about what happened yesterday. Second, a total lack of private data. It has never seen your proprietary database, it hasn't seen your internal company wikis. Because of this, if you ask it an internal question, it usually won't just politely say, "I don't know." No, it'll often confidently just make up facts that don't exist. And that is what we call a hallucination. To really understand why it hallucinates like that, we need to quickly define what this neighbor actually is. We're talking about an LLM, a large language model. And listen, it is not a search engine. It's a massive, complex mathematical model. We're talking hundreds of billions of parameters, which kind of act like tiny memory cells storing learned patterns. So when you ask it a question, it is not looking things up in some giant database. It's actually generating brand new text on the fly by calculating and predicting the next most logical sequence of characters based on all those patterns it learned during training. Now, what's genuinely fascinating is how these models process that text. They actually don't read words, they read tokens. A token is basically the fundamental unit of language for an LLM. It's usually about 3 to 4 characters long. So a short word like Java, that's 1 token. But a slightly longer word like microservices, that actually gets split up into 2 tokens. And understanding this is absolutely critical for us as developers, because every single API call you make to an AI model is priced, measured, and constrained by tokens. The more tokens you send over, the more compute power it takes, and ultimately, the more it's going to cost you. And because tokens are so computationally expensive, every single model has a hard limit, which is called a context window. You can think of this context window as the LLM's short-term memory, or like its RAM. Some models can hold, say, 128,000 tokens, others might be able to hold 1,000,000. Within that specific window, the AI can reason flawlessly. But once you exceed that token limit, the oldest information just gets chopped right off and completely forgotten. This is exactly why you can't just take a massive 500-page internal company manual, dump the whole shebang into an AI request, and expect a good answer. You've got to manage that context window intelligently. So how do we actually communicate with the model efficiently? Well, it all comes down to the prompt. A professional production-grade AI prompt isn't just a simple string of text. It's highly structured. It usually breaks down into three distinct parts. First, you have the system message, which basically gives the AI its persona and its rules, like telling it, "You are a helpful enterprise Java assistant." Second is the user message, which is just the actual question you're asking. And third is the context. This context section, this is our secret weapon. This is the exact space where we're eventually going to inject our private, highly relevant enterprise documents so the AI actually knows what we're talking about. Which brings us to Section 1. Enter Spring AI, the magic sword for Java devs. You know, bridging the gap between Java and AI used to be a massive headache, but Spring AI, it literally changes everything. To really grasp what it does, let's ground it in something you're probably already super familiar with, Spring Data. Think about how Spring Data works for a second. It gives you this beautiful abstraction layer, so you don't have to sit there writing messy, boilerplate SQL queries or stress about exactly which database vendor is running under the hood. Well, Spring AI does the exact same thing, but for AI. It completely abstracts away all those complex, messy REST API calls to various AI providers and wraps them up in a clean, very familiar Java architecture. And this abstraction layer, it gives your projects incredible flexibility. Because Spring AI abstracts the API itself, it means you can seamlessly swap between different AI providers without ever touching your core business logic. Seriously, want to use OpenAI in the cloud? Done. Prefer Anthropic's Claude or maybe Google Gemini? Easy. What if your company has super strict privacy requirements and you need to run a local model right on your own hardware using a Llama or DeepSeek? You can totally do that too. You literally just swap your dependencies and properties, and your underlying Java code stays exactly the same. It's brilliant. Plus, the way you actually write that code is such a breath of fresh air. Spring AI gives you idiomatic native Java APIs. So instead of dealing with raw HTTP calls, you're using a chat surf client that works beautifully, almost exactly like a web client, complete with a super clean, fluent builder pattern. You get a vector store interface that's going to feel exactly like a Spring Data repository. You get an embedding model that acts just like a standard Spring converter. It strips out all that tedious boilerplate, and best of all, it entirely removes the need to drag Python into your tech stack. Moving on to Section 2, the RAG solution, or giving the neighbor a manual. So the crucial point is, we now have these perfect tools to connect to AI models natively in Java, right? But how do we actually solve that isolated neighbor problem we talked about? How do we give the AI access to our internal data without just blowing completely past that context window limit? Well, the industry standard answer for this is RAG, which stands for Retrieval Augmented Generation. Let's think back to our neighbor analogy. If the neighbor doesn't know your company's HR policy, you don't force them to sit down and memorize the entire manual. No. Instead, right before you ask them your question, you search through the manual yourself, you rip out the one specific highlighted page that has the answer, you hand it to them, and you say, "Hey, using only this page, answer my question." That is exactly what RAG is. Let's walk through the exact step-by-step flow of how Spring AI executes one of these RAG pipelines. Step 1. The user asks a question about some private data. Step 2. Spring AI takes that question and searches through your internal documents, which, by the way, are stored in a specialized vector database that actually understands the meaning of the text, not just basic keywords. Step 3. It retrieves only the most relevant little chunks of text, which completely protects your token limits. Step 4. It injects those specific text chunks right into the context part of the prompt we talked about earlier and sends the whole package over to the LLM. And finally, Step 5, the LLM reads your private context and hands back a perfectly accurate, grounded answer. Hallucinations are entirely prevented, and your private enterprise data remains your single source of truth. Wow, we have covered a tremendous amount of ground in this explainer. From breaking down what LLMs and tokens actually are behind the scenes, to seeing exactly how Spring AI provides this perfect idiomatic abstraction layer for us, to finally solving the big private data problem using retrieval augmented generation. Honestly, the era of Java developers sitting on the sidelines of the AI revolution is officially over. You've got the architecture to build some incredibly powerful tools right now. So I'm going to leave you with this one provocative thought. Now that the language barrier is completely gone and you can leverage top-tier AI entirely within Spring Boot, what enterprise AI feature are you going to build first?